Good day everybody, we got an interesting question that is connecting a circle and a parabola. So let me write the question down. Let P be the point on the parabola y squared is equal to 4x, which is at the shortest distance from the center S of the circle. X squared positive, y squared negative 4x negative 16y positive 64 is equal to 0. Let Q be the point on the circle dividing the line segment SP internally. Then we have to find the following. We have to find SP, we have to find SQ, we have to find QP, we have to find SQ ratio QP, we have to find the x-intercept of the normal to the parabola at P, and you have to find the slope of the tangent to the circle at Q. So we have to find all of these. Now just to go back to the question and pick out the key points. The foremost key point is of course we are given a parabola and a circle. A parabola is given, a circle is given, and then the connection is that the point P, which is on the parabola, is located at the shortest distance from the circle. So foremost, let me draw this. So we have the x and y axis. So this is the x-axis, this is the y-axis. Now we have a circle somewhere over here and a parabola over here. So we have to get the parabola. So let me draw the parabola. So this is 0. So we need to get the circle there. Okay, this is a fairly good depiction of the circle. Okay, let me move on. So we have the circle. Now the center of the circle is given as S the center. Okay. So we will have to look at the center, and then you have P, which is a point on the parabola which is at the shortest distance excuse me, from the circle, right? So P is the point on the parabola y squared equal to 4x, which is at the shortest distance from the center. So if you want to get the shortest distance, it is the line that is perpendicular to the circle. So if I were to draw this line, which is perpendicular, that would be the shortest distance. So this is actually the line that is directly hitting or connecting the center with the point P at an angle of 90 degree. Okay, so this is the normal to the point P. That is a very important observation that is already given there. So let Q be a point on the circle dividing the line segment. So this is the next point. So this point is Q, which is dividing the line segment internally. So it's straightforward division. Now these are the requirement that we have to start off. So the first requirement is find the center of the circle. That's the first requirement. Now the second requirement is we have to find the equation of the line that is normal to the parabola y squared is equal to 4x. So this is the parabola y squared is equal to 4x. So these are the first two requirements that we will be dealing with for this particular question. So having mentioned you that, foremost let me go and consider the given. I'll be using this space here. So this is given. Given is x squared positive y squared negative 4x negative 16y positive 64 is equal to 0. Now let me club x squared negative 4x and y squared and 16y. Of course I will leave the constant out, 64. I'm clubbing these two together. Now I would like to write this as a perfect square. So can I write this as x negative 2 whole squared? If I were to do that, I would get x squared negative 4x, positive 4 is coming there. So I subtract the positive 4. Can I write this as y negative 4? If I do that, I get y squared. Oh, this should be 16, right? So I cannot write it as 4, I will have to write it as 8. So that is going to give me 16y plus a 64 is there. So I will have to remove the 64. And there is already a 64. So this would be the equation of the circle. So let me simplify this. X negative 2 the whole squared positive y negative 8 the whole squared. Negative positive goes off. You have a negative 4. I'm going to throw that negative 4 to the other side. Excuse me. Okay. So if 2 squared. So this can be further rewritten as x negative 2 the whole squared positive y negative 8 the whole squared is equal to 4. I'm going to write it as r squared. Now this is of the form x negative a whole squared positive or x negative h the whole squared positive y negative k the whole squared is equal to r squared, where h comma k are the center and r is the radii. Okay, so in this question, therefore the center of the circle is what? Center of the circle is 2 comma 8 and the radius is 2 units. So go back to the figure. So this is going to be 2 comma 8 and SQ is a point, right? It's a point on the circle. So SQ is equal to 2 units. So we have already got this one. So you can put the box there. And we will have to get the other things, right? So SP we will have to get. So for that, we will have to find the equation of the normal. So let me go to the next side, and let me give you this. This is the important equation. The equation of the line that is normal to y squared is equal to 4ax. Okay, is given by, so this is the formula. Normal to y squared is equal to ax at the point, say 80 squared comma 2at is given by y positive tx is equal to 280 positive 80 cubed. So this is the formula. Now for the problem, we have y squared is equal to 4x. This means a is equal to 1. So therefore 1 can be rewritten as y positive t times x is equal to 2t positive t cubed. Okay, now watch here. The normal, the point P is the shortest distance from the circle, and that is only possible if the line is actually passing through the center. So the normal is actually passing through the center of the circle. Okay, that's exactly what I'm going to write. Since the normal passes through the center S of 2 comma 8, so this is going to be 2. 2 can be rewritten as 8 positive 2 times t is equal to 2 times t positive t cubed. So 2t gets cancelled, so t cubed is equal to 8. This implies t cubed is equal to 2 cubed. This implies t is equal to 2. So hence 2 can be rewritten as y positive 2 times x is equal to 2 of 2 positive 2 cubed. So y positive 2x is equal to, this gives me 4 positive 8, which means I have y positive 2x is equal to 12, which means y is equal to negative 2x positive 12. So the slope of the normal is equal to negative 2. This means the slope of the tangent to the normal is equal to negative 1 over m, which is nothing but negative 1 over negative 2, which is equal to 1 over 2. So this one we have got the slope of the tangent to the circle at P, to the circle at Q. So what are they exactly asking us? So we have got the slope of the normal, right? Now anything that is tangential to this normal will have the slope which I mentioned. So what they are asking is, they are asking us to get the slope of the tangent. So definitely the slope of the tangent in Q is actually going to be perpendicular to the slope of the normal at P. So this is going to be 90 degrees. So that's exactly what I've got. So I already got answer to question number 6. So slope of the tangent and normal is negative 1 over m, which is equal to 1 over 2. So this is question number 6. Probably you can actually place it in a box like that. Question number 6. Okay. So far, what are the things we have got? Okay, now we can get SP. Okay, so how do we get SP? Since the point is t squared comma 2t, this means p of 2 squared comma 2 of 2t is the point P. Okay, so which means we have P to be as 4 comma 4. So this in turn means, so why do we say that P is t squared comma 2t? The fact we say P is t squared comma 2t because the equation of the line that is normal. So P is actually the point that is normal to the parabola. So the point we are talking about is the point P, which is actually the normal line. So that is the reason I have placed here P of t squared comma 2t. So we have got P of 4 comma 4. Now we have to get SP. So what is SP? SP is nothing but 2 comma 8 and what is P? 4 comma 4. So therefore SP is equal to distance formula root of 4 negative 2 the whole squared positive 4 negative 8 the whole squared. So this is equal to 2 squared positive 4 squared, which is equal to root of 4 positive 16, which is nothing but 20. Now I can write, I'm using this space here, I can write root of 20 as 5 times 4, which means root of 5 times the root of 4, which means 2 times the root 5. So this is my SP. So SP, which is our first question, is now got 2 times root of 5 units. So you can, okay, excuse me. So after getting this, let me go back to the figure. So we have got SQ, we have got SP, which is 2 times root 5. Now we will have to get QP. Now let me go back to this page. Now what is QP? QP is nothing but SP. From SP you have to take away SQ. From SP you take away SQ. So what is SP? SP is 2 times root 5. What is SQ? Is nothing but the radius, right? SQ is nothing but the radius. So this has to be removed. Is that not? So if you were to remove this, so what do you get? You get QP. QP is 2 times root 5 negative 2 units. So now comes the next part. What is the next part? SQ used SQ is to QP. Okay, so we need to get this. So that means we are talking about the ratio. So let me and find the ratio. Hence SQ is to QP is nothing but SQ over QP. My SQ is 2 units and my QP is 2 times the root 5 negative 2. So this is going to be 2 over 2 of root of 5 negative 1, which is nothing but 1 over root of 5 negative 1. You multiply it by root of 5 positive 1 divided by root of 5 positive 1. This is root of 5 positive 1 divided by 5 negative 1, which is root of 5 positive 1 divided by 4. So this is my SQ over QP. Okay, now we have got this, 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 we have got this. Now x-intercept of the normal to the parabola. Now what is the normal? We know that the equation of the normal to the parabola at P is given by, so what is the equation? It's given by y is equal to negative 2x positive 12. Y is equal to negative 2x positive 12. So to find the x-intercept, what should we do? We put y is equal to 0. So 0 is equal to negative 2x positive 12. Negative 2x is equal to negative 12. So x is equal to 12 over 2, which means x is equal to 6. So this is the x-intercept. Okay. So that is the conclusion for this beautiful question. Thank you everybody. Please like, share and subscribe.